Okay, here's example 10 in the differentiation topic. We are working on the quotient rule. We've done two examples, example 8 and 9. If you haven't tried them, you can give them a go perhaps first. This is a little bit of development. We've got a function, we've got a function cos x over sine squared x, and as well as finding the derivative, we're actually asked to find, or substitute into that derivative f dash of pi over 4. So we'll find the derivative, and then we're going to find the value when we substitute pi over 4 in for x. So it would be the equivalent of finding the gradient of that function at x equals pi over 4. Okay, so normal rules apply. We first of all determine that the function that we've got is, we've got two terms in x, we've got a fraction one term over the other, so we can use the quotient rule. The quotient rule tells us that f dash x then is going to be u dash v minus uv dash over v squared for a given set of terms, u, which is our numerator, and v, which is our denominator. Differentiating, first term's fairly straightforward. Cos x differentiates to negative sine x, but remember that before we differentiate that, we can think of sine squared x as sine x squared. I prefer to rewrite that with a bracket just to remind you that it is the chain rule, and we're going to have 2 sine x to the power 1 effectively multiplied by the derivative of the term in the bracket, which goes to cos x. Sine x differentiates to cos x. So the simple or a simplified version of that would be 2 sine x cos x, and if you remember your, that's v dash of v prime. If you remember back to previous maths courses, you will probably remember that 2 sine x cos x is another way of writing the double angle formula sine 2x. That's probably the shortest way to express the derivative. So we take these into the quotient rule. So the derivative we're looking for is u dash negative sine x multiplied by v, which is sine squared x, minus u, which is cos x, multiplied by v dash, which is sine 2x, all over v squared sine, well, I'll just write it down. That is one thing we can simplify. I'll write it down like that just now. So we can simplify the numerator a little bit. Negative sine x times sine squared x multiplying sine x by sine squared x is sine cubed x, so it's negative sine cubed x. Second one here was, there's nothing really we can do. Even if we went back to the previous version of v dash, it would just become 2 sine x cos squared x, which is not any better to work with. So I'm just going to write down minus cos x sine 2x, but I'm going to simplify the denominator just to make it sine x to the power 4. We know that that's going to be the case. So we can do that. There is a way of simplifying it a lot. I could split up the numerator into 2. I could have negative sine cubed x over sine x to the power 4 and simplify that. But at the moment, let's just leave it like that because we're going to substitute in, so it doesn't really matter. So we want f prime of pi over 4. So we want to say when x equals pi over 4, then what's the value of this? Okay, so we want negative sine. We're going to reintroduce the brackets where these powers are. So we've got sine pi over 4 cubed minus cos pi over 4 times the sine of 2 lots of pi over 4. 2 lots of pi over 4 is pi over 2. And sine x to the power 4 is sine pi over 4 to the power 4. So we want to evaluate all these different functions here. Sine pi over 4 is 1 over root 2, or root 2 over 2. What shall we do? Let's use root 2 over 2 cubed minus, we've got another one, root 2 over 2 times the sine of a half is 1. All over root 2 over 2 to the power 4. If we evaluate that, we then get 2 root 2 over 8 minus 2 root 2 over 8 minus root 2 over 2 divided by, that becomes 4 over 16. And we can evaluate that by saying we've got negative 2 root 2 over 8 minus 4 root 2 over 8. Instead of dividing by a quarter, that's the same as multiplying by 4. So we end up with negative 6 root 2 over 8 times 4. They cancel out, and we end up with negative 3 root 2. Okay, so there's our answer. So f dash pi over 4 has a value negative 3 root 2.